Now let us take the case 2. Electric field on the equatorial line of a dipole. So let us consider an electric dipole and find the electric field at a point on its equatorial line. So let me take an electric dipole, which is just a combination of equal and opposite charges, plus q and minus q, separated by a very small distance, say 2a. Center of the dipole, say O. Now where is the equatorial line? It is the line passing through the center perpendicular to the axis. So this is an equatorial line. Let me consider some point P where I want to find the electric field. Now the distance of this point P I will take from the center of the dipole to point P. I will take the distance as r. Let r be the distance from center to P. Then at point P, what is the electric field? Due to plus q. Due to plus q, let me say the line joining the charge with P is, with the point P is this. Okay, let me just draw a line from Q to P. Now this is the line joining Q to P. The distance is, say, x. Then at point P, the field is, away from the positive charge. I will call it as E plus Q. Now same way, what is the electric field at point P due to minus Q? Due to minus Q is here. Due to minus Q, say this is the line joining, and the electric field is same in magnitude as E plus Q, because both are same charges, identical charges in magnitude. This is E minus Q. These are the two fields, E plus Q, E minus Q. Then, of course, just to avoid confusion, let me just take the other line here. Okay, E plus Q, E minus Q. Now, what is the resultant of these two? Of course, by using parallelogram law of vector addition. So, how to do that? So, according to parallelogram law of vector addition, so if I complete a parallelogram with these two vectors, then here is the resultant. So this is the resultant electric field, which is E. So net electric field at P is E, which is the vector sum of E plus Q and E minus Q. What is this E plus Q? The electric field due to plus Q at a distance x. So how much is that? So first, electric field at P due to positive charge. So that is E is equal to 1 by 4 pi epsilon naught. Of course, E plus Q I will call 1 by 4 pi epsilon naught into charge divided by distance square, which is Q divided by x square. Now what is this x? X is x can be found out from this triangle. Say for example, this angle, if it is theta, that is E plus Q to E, then same way here also it is theta. So then if this is theta, what is this distance? It is half of 2a, that is a. So this is a, and what is this distance? It is r here. So you take cos of theta, for example, or so you can take like that. So what is cos of theta? Is adjacent by hypotenuse, that is a divided by x. Now what is x? Let us just check that. Now first of all, from Pythagoras theorem, what is x? Is equal to root of a plus a square plus, this is a square plus r square root. So x is equal to root of a square plus r square. So which is nothing but a square plus r square power half, we can say. Then what is cos theta? That also I'll just find out and keep it ready here. Cos theta is equal to adjacent by hypotenuse, which is a divided by x, which is equal to a divided by a square plus r square over half. So anyways, this is, let it be as it is. For the time being, let it be as it is. Q divided by x square. Now same way, let us find out what is the electric field due to E minus Q. I don't think it is any different. Say E minus Q is the charge distance between these two is Ax, which is same as this, and the distance of these two is also A, same as that. So therefore E minus Q is nothing but 1 by 4 pi epsilon naught into Q divided by again x square only. So E minus Q is also equal to 1 by 4 pi epsilon naught Q divided by x square. So E plus Q and E minus Q are same. Now how do you find the resultant of these two? Now say let us split this E plus Q into two components, one vertical component, one horizontal component, or you can say equatorial component and axial component. This is the axis and this is the equatorial line. So E plus Q has two components, equatorial component, axial component. Now equatorial component is upward, remember that. Now same way, let us divide this E minus Q also into two components, equatorial and this minus E minus Q is equal to equatorial axial line and equatorial line. So two components. So the equatorial component of E plus Q, which is upward, equatorial component of E minus Q, which is downward, they cancel each other. The magnitude wise they are same, hence they cancel each other. Now what is left out then? This has component along axial line, which is EQ cos theta. Same way E minus Q cos theta. They are the axial line components. So the net field the net electric field P is given by what? E is equal to E plus Q cos theta plus E minus Q cos theta. But magnitude wise both are same. E plus Q is nothing but E minus Q in magnitude. Therefore 2 times 1 by 4 pi epsilon naught Q divided by x square. This is the net field. Now you know what is x. So let us just substitute that here. And of course cos theta as it is. So let us substitute x and cos theta in this. So this is nothing but E is equal to 2 into 1 by 4 pi epsilon naught into Q divided by x square. So let's take this is Q. Now x square, x is whole square, a square plus r square root. So half of 2 and half gets cancelled. So x square is nothing but a square plus r square power half and square gets cancelled, whereas into cos theta is a divided by a square plus r square power half. So this is Q. Okay, now this is nothing but equal to, so let me just take 1 by 4 pi epsilon naught here, 2QA divided by a square plus r square, a square plus r square, a square plus r square, 1 and half. So that is 1 and a half, which is nothing but 3 by 2. So that's the total field. Or I can say 2QA is nothing but by 4 epsilon naught. 2qa is nothing but p divided by a square plus r square whole power 3 by 2. This is E. So the direction wise, it is same as, say, the direction of E is same as, is from minus q to plus q. Is, you know, dipole moment is minus q to plus q. So whereas electric field is opposite to that, therefore I'll put here minus p. So this is the electric field at a point on the equatorial line of a dipole. So in case if I take the distance r and a comparison, like, you know, a is the dipole, half dipole length, and r is the distance on the equatorial line. Assuming that if this is a dipole, plus q and minus q, center is here, the distance is very small, and t is at very large distance on the equatorial line. So r is very much greater than a. So in that case, what will be the electric field? So let me just write it here. If r is very much greater than a, that is distance of point P is very much greater than the dipole length or half of dipole length, then I'll ignore a in presence of r. So thereby we will find the net field is equal to 1 by 4 pi epsilon naught into P divided by, what is this? So r is large, a is small, so a goes, so r square power 3 by 2, which is r cube minus p cap here. So this is the electric field on the equatorial line. Equatorial line. And what is P here? 2qa is the dipole moment. So that's the electric field on the equatorial line of a dipole. Thank you.